Hello everybody. Today we're going to learn about game development within the Golang coding language. Now, Golang is a really great coding language. The only issue is that there isn't that much support. This is mainly because Golang is relatively new. Now, inside of the game development space, it tends to lack the most when compared to other, fields. So today I'm going to be showing you guys how to make a game using a library called go-raylib. Now, go-raylib is in several different languages, and there's a port of it in Go that is available. I will show that a bit more later. Now, I'm going to be guiding you guys how to make a game similar to that of flappy-bird, but there's going to be a bit of a twist. I call this game Flappy Apples. In fact, let me show you right over here. You are this bird called Flappy, and there are these apples that you eat. Now, each time you eat one, you gain a point. Now, let's suppose if I were to miss this apple, right, then I actually lose a point, all right? And similarly, if I die, then the game ends, and that's my final score altogether. All right? So that's what the game is. Now, it is a bit simple, but the idea is that this is just like an introductory, and hopefully in the future, we could get into more and more deeper video games. All right? And also, there's some audio inside of here. You guys probably can't hear it because my speakers are turned off, but I will show you guys how to set that up in the tutorial. So without further ado, let's begin. All right, so first of all, what is go-raylib? So go-raylib is a simple and easy to use library to help make video games. All sorts of video games can be made here, and the only limit would really be just your imagination. All right, now it's ported over, as I said earlier, to multiple platforms. All right, so if you have Mac, Windows, Linux, or basically anything, it should work. Now there's different bindings available, so we're going to use the Go binding over here. Now if we click over it, okay, we get all of this nice documentation. The only issue is that, reading through this is really hard, especially for beginners. That's why I'm here to sort of, make that easier. Now, inside of this documentation, you don't really need to download anything. All except one thing. See this installation command right here? I'm just going to zoom that in. All you need to do is go ahead and copy this, all right? Zoom out, close that, and go over to your terminal, all right? And it doesn't matter what platform you have, as long as you have Go installed, right? Okay, and as you can see, it just downloads perfectly. All right, now we're going to begin the actual code. All right, so the first thing you're going to want to do inside of your code is create a file, and just go ahead and call that main.go. Now, make sure that the file is inside of a folder, all right? And the reason why I'm saying this is because you're going to have a couple of more folders as well. Now, you're going to have two folders. One is a sound file. Inside of here, you're going to have some sound effects. We only have one called eat.wave. But I'm going to teach you guys how to integrate sound into your game, and you guys can really insert any other sound effects you want. Now, inside of assets will be any image-related work. So there is two images that we have. We have a bird up and a bird down. We will use the bird up when it's flying, and a bird down when it's, what's the opposite of flying? Falling. Now, you guys can also use your own images. Make sure there's some normal image file like JPEG or PNG, and also make sure to know the image size and if it's not too big. And the reason why I'm saying this is because we're going to need that when working with our collision detector. But that's a story for later on. For now, let's just start with our boilerplate code. All right. The first line of code that we're going to write is just package main. This specifies that it's a main package to run. Now, the next thing I'm going to want to do is go ahead and import the go-raylib module. So you just go import, and the way we're going to import this is we're just going to copy over the GitHub link that I showed earlier. All right, and that's also the same go get command. All right, now that that's done, what I will do now is just go into my main function. All right, and inside of our main function, first, what I want is there just to be a white blank game screen, right? So first of all, I need to specify a width and a height for that screen. So make two variables. The first variable will specify the width, and the second one will specify the height. Now, go-raylib works with int 32s, not the int 16s that come default with Go. So I'm going to use an 800 by 450, or actually 450 by 800 screen size. All right, screen, what's it called again? Screen height. All right, I'm going to set that equal to another int 32, and that's just going to be 450. Now let's create our window. To make the window, we're going to go RL init window. Okay, and once we've initialized our window, we'll go screen width, comma, screen height, and then we're going to give the title. The title is what you're going to see up here. Now, like over here, we see main.go, and then a dash and flappy-bird go. Similar to, so similar to that, all we will write is flappy apples. Okay, now the next thing we're going to want to do is go ahead and make a proper FPS state. Now, by default, all games will run, most games run on a 60 FPS state. Now, I wouldn't suggest going anything lower or greater. The reason why I won't say to go greater is because it might, make your GPU work a lot more for a very small game. And don't go less because we don't want Flappy Bird to be too slow. So to set up your FPS, you're going to go set target. All right, you're going to go set target FPS. All right, and you're then just going to specify the value of the FPS. So I'm going to use 60 frames per second. All right, now the next thing we're going to want to do is just go ahead and draw everything we have so far. In order to draw everything you have so far, what we need to do is just create a while loop. This while loop, or actually a for loop because it's in Golang, this for loop is never going to stop unless the game crashes. So all we're going to do is simply make a not operator, which is the exclamation mark, and go not rl.window should close. Okay, and inside of here, first of all, we're going to begin drawing, rl.begin drawing. All right, then the next thing we're going to want to do is go ahead and specify a background color. So I'm going to use rl.clear background. Okay, clear background, and it's just going to be rl.ray white. All right, so this isn't pure white, but it's a little close to that. Okay, the next thing we're going to want to do is just write rl.end drawing, like so. And that just ends our drawing, right? So each time this for loop ends, we're just ending the drawing, and then we're going to restart it once more. All right, and let's suppose if I've somehow exited through, all I'm going to do is just go ahead and close the window. So it's going to go rl.close window, like so. Okay, now to run this, all we have to do is just write go run main.go. rl.begin, begin drawing. All right, so now I've run that, and I should see a window. Okay, so it was on my other screen, but you guys can see it right over here. So as you can see, we have the word flappy apples right there, and we have our clear background. So now we've successfully created a proper window. Now let's load in our assets. All right, so now we're gonna load in our image textures. And by that, I mean the bird up and the bird down PNG. All right, so in order to do this, just go ahead and create a variable called textures, and make sure that this is done before the while or the infinite for loop, I guess. Okay, so I'm just gonna go ahead and call that texture. All right. Okay, and then I'm gonna do a declarative operator and go ahead and just load in the image. All right. Dot load texture. Or actually, wait. From image. Okay, wait. Before I actually load it into the texture, I have to first load the two images. So I have two images, as I said earlier. I have an image down and or a bird down and a bird up. Underscore up. Okay. Now I'm going to add a declarative operator and just go rl.loadImage. Okay. rl.loadImage, and then I'm just going to specify the path where my image is located. So it's just going to be assets / bird up dot png. Okay, and I'm going to go ahead and repeat this for the bird down, right? Okay, so now that that's done, what I need to do is go ahead and just load one by default, all right? This is because I can't leave texture empty, okay, because Go is very, keen on that. So by default, the bird's going to just be flapping in an upwards position, right? Okay. And now, over here, I'm going to want to go ahead and load in the texture. Even though I've created my texture, I still need to load it in. So before I'm going to load that in, the first thing we need to do is specify some x and y coordinates, all right? So make two variables, one called x-coords, all right, and make sure it's an int32, all right? And by default, the x-coordinates will always stay at the center of the screen. This is because if you remember in flappy-bird, they never actually, the bird never moves, it's only the pipes that move. So in order to get the center of the screen, what we're going to do is we're going to take our screen width, all right? And then we're just going to divide that by 2. Then we're going to go ahead and grab in the texture's width, all right? Texture.width, all right? And what we're going to want to do is just go ahead and divide that by 2 as well, all right? And that will give us that will just center in our x-coordinates. All right, now what we're going to want to do is go ahead and repeat that exact same method for the y-coordinates, all right? So we're just going to go var y-coords and set that equal to an int32. All right, and this time we grab the screen height. All right, go ahead and divide that by 2. Then what we're going to do is we're going to minus that with texture dot height. All right, and divide that by 2 as well. All right, and what we're going to do is we're just going to minus 40. All right, this is because we don't want we don't want our bird to be all the way at the top. All right, we want it to be like a little bit lower. All right, so now that that's done, now that that's done, what we're going to do is go ahead and draw in our texture. So right after begin drawing, we're going to write it right here. All right, so we're going to go rl dot draw texture. Okay, and inside of draw texture, we're going to first of all specify the texture that we're loading. All right, then what we will do is specify the x-coordinates. Then we're going to specify the y-coordinates. All right, then we're just going to go ahead and specify the color, rl.white. So this is just the background color. All right, it's not really going to matter because it's a PNG, and as a result, it's it's transparent, right? But we need something inside of there in order for there to, be in order for there to. Otherwise, it's just going to run an error. Oh, and I also see that I made an error here. It should be screen height like that. Okay. All right. Now let's just go ahead and run this. Unexpected. Oh. Okay. And one more thing that we also need to do before, running this is I'm going to just go ahead and create my character controller. So my character controller is actually going to be really simple. What it's going to do is it's just going to check to see if there is a key space. And if there's a key space, the bird is going to flap up. And if there's no key space pressed, then it's going to flap down. So to do this, just run a simple if statement inside of our for loop. So we're going to go if rl dot is key down, all right? And we're going to take in the variable, or we're going to take in the key value, key space, all right? If that is true, then just set texture equal to rl.loadTexture from image, and it's just going to be bird up. Otherwise, texture is equal to rl.loadTexture from image, bird down, or bird down. Okay? Now I'm just going to go ahead and run that. So, whoa. Okay. So it's right over here. So currently I'm not pressing the space button. As a result, it's just going to continuously render the texture as down. But watch what happens when I press the space button. The image changes, all right? And yeah, that's all there is to it. That's how you basically make a character controller, all right? Now you might be wondering, how can I make it so that it feels like it's falling and rising? Well, to do this, all we have to do is mess around with the y coordinates. All right, we keep our x coordinates constant because, as I said earlier, the bird stays constant, right? So let's suppose if I'm pressing the key space button, then all I do is I simply take the, what's it called? I simply take the y coordinates, all right, and add 5 to it, okay? And when it's going down, I'm just going to go ahead and subtract 5 from it. All right, now let's just go ahead and run that. Okay, nope. Y coordinates. Okay. If we take, oh, whoops, I think I just messed these up. There we go. There we go. Yeah, so as you can see, that's how we get our bird to move up and down. All right, so when it's not pressing it, the y coordinates will decrease, and when I'm pressing it, it will increase. Now, as you can see, this is a little bit too fast. Now, this is going to be a bit of a problem because, you know, we want this game to be really simple and easy. All right, so if you guys want to keep it at +5, feel free to. I'm just going to go ahead and just, you know, minus it by 1 and add it by 1. All right, now if I were to run this, as you can see, it's just much easier to play with. All right, okay. Now that that's done, the next thing we're going to work on is our apples. Hi, future me here. I forgot one more thing I need to tell you guys about, and that's about unloading textures. So in order to so the reason why I'm telling you guys about unloading textures is because when you guys create textures here, like if I were to just show you, we made a texture for the images, right? Now what happens is that when we exit out the program, right, it doesn't properly, you know, remove itself, right? And that can sometimes lead to memory leaks or, you know, just make our program, or make our computer slower, right? And it could just throttle our GPU as well. So in order to unload our texture, what you're going to want to do is go after the infinite for loop and just go ahead and go rl.unloadTexture. Okay, and the texture that you're going to unload is simply just the texture. All right, now if I were to, god damn it, yeah, now if I were to, you know, go ahead and play this game, hold up. Okay, there we go, yeah. Now if I were to just go ahead and play this game, right, and I just quit it out, all right, it tells that you've unloaded the texture from the VRAM, also known as the GPU. If you don't unload your texture, what's going to happen is that it's just going to stay there, and it might get overwritten later on, but it's just not good for your hardware. All right, now the next thing we're going to work right now on is on our apples. All right, so in order to add apples, right, so there's multiple different ways to do this, and one of them is just to, you know, randomly generate its y coordinates. All right, and then just simply just take the x coordinate and keep subtracting that, right? And the idea is that you could spin up multiple instances of that same apple with random coordinates, right? So we personally are just going to use one apple to make the game easier, but the way that I'm coding it will make it super easy for you guys to add in another apple or, you know, more apples as the game goes on. So first thing you're going to want to do is go ahead and create a struct. Now this struct is going to be very similar to how a class acts, and it's going to have like the basic DNA as to how our pipe will, or our apple will work. Okay, so I'm going to go ahead and call this struct, I'm just going to go ahead and call it apple, right? Okay, and now it's going to take in the argument of it's going to take a couple of arguments. First, it's going to take the x position, and that's just going to be an int32. All right, well, let's go like that. The next thing it's going to take is our y position, which is once again int32. The next thing it'll take is its width, int32. Then it's going to take in the height of the, you know, the height of the apple, which is once again int32. And I spelled that wrong. All right, the next thing I'm going to go ahead and do is take in the color. Now this is going to be the color of our apple, which is just going to be obviously red. Now, even though the color will be constant, I still need to specify it because we're going to be using a rectangle, right? And these are all the values that are required by the rectangle class inside of Raylib. All right. Now the next thing we're going to want to do is go ahead and instantiate the next thing we're going to want to do is go ahead and create a randomly generated y value. So to do this, go ahead and import the random library. That is just simply math/rand. All right. Okay. And we're also going to want to use the time module. All right. So you're going to want to import time. These are all necessary for two things. One is to slow down the game, and two, in order to randomly generate a y coordinates. All right. Now down here, the first thing we're going to want to do is go ahead and generate our y coordinates for that one apple. So let's just write it over here. Okay. So how do I do this? Okay. So first I'm going to do is just go ahead and set up a random. So like I'm going to have to set up a random seed. This is required inside of Go in order to randomly generate a number. All right. And .now .unix nano. Okay. So this is going to allow us to run random, run random commands. Okay. So what's the problem here? Okay. So the next thing we're going to want to do is go ahead and create a random number. So var, all right, I'm going to call this position apple lock because that's just going to be its location, and set that equal to rand.intn, or so that just generates an integer, and then I want it to be within our y values, right? So it has to be over here between 0 and 450, but I don't want it to be right at 0 because then it's going to be too hard for the player to grab the apple. So instead, let's just elevate it by 2. So to do this, I'm just going to go 450, all right, minus 2, plus 1, and then just go ahead and subtract 2 once again. All right. Okay, and make sure to save this as an integer. All right, now the next thing we're going to want to do is go ahead and create a bunch of apples. Or we're going to want to create like a main array of structs. So this is just going to be apples, which is simply just an array of the regular apple struct. Apple. So, okay. Or wait, wrong one. There we go. Okay. Now that that's done, first thing we're going to want to do is go ahead and create one struct and then import that into our array of structs. So I'm going to call this current apple, okay? And it's just going to be equal to the apple struct module, right? Apple. And I'm going to specify first of all, where the apple is going to start. So the apple is going to start at the end of our screen, which is right at the end with the screen width. So I'm going to go ahead and set that equal to screen width. You could also set that equal to 800. All right, then I'm going to go ahead and just grab the randomly generated number, which was apple lock. Okay, the next thing I'm going to want to do is go ahead and give it a size. I'm going to give it a simple 25 by 25. And then I have to give it its color, which is just going to be RL.red, because apples are, you guessed it, red. What's the problem here? There we go. Okay. Now the next thing you're going to want to do is go ahead and append this over into the apples. So to append it, what you need to do is just go apples and is equal to append the apples and current apple. Okay, perfect. Now that that's all done, what we're going to do inside of our window should close is go ahead and loop through every single struct and go ahead and draw that onto our screen. All right, but before we do that, there's two things that we need to do. The first thing I want to do is go ahead and actually make our bird a bit faster. So instead of minusing it by 1, go ahead and add it by 5. I know I told you guys not to do this earlier, but I've realized now that it's much easier if we go ahead and do this. All right? And the reason why I'm saying this is because even though it's moving really fast, we're actually going to slow it down. In order to slow it down, we're just going to go ahead and wait the loop before rerunning again. I'm going to make it wait for about 5 seconds. So 1, 2, 3. Okay, there we go. All right, so now it's asleep, right? So now you're going to notice that the Flappy Bird will move a bit slower now. and it's still going to have that same, it's going to be a lot more smoother than it was before. All right, now let's loop through our infinite for loop. Okay, so the way we're going to loop through this infinite for loop is pretty easy. So we will do this right after our if-else statement for our character controller. All right, and inside of here, we're going to make a for loop. It's going to have two things, the IO, like an IO, and the current apple. Okay, and it's going to have every single range of apples. Range apples. Okay? Okay, now that that's done, the first thing we're going to want to do is go ahead and draw the rectangle. So in order to, so we're going to go rl.draw rectangle, okay? And what we're going to do is we're going to take in our current apple, and we're going to take in our x position, then we're going to specify our y position, then we're going to go ahead and specify our width. Current apple dot width. All right, and then we're going to go ahead and specify the height, and this is going to obviously just be the height of our apple, right? Current apple dot height. Okay. Whoops. There we go. All right. After that, what we're going to want to do is go ahead and give it the color, which is just current apple dot color, which is also red, but we're still going to, write it like this. In the case that we ever, don't do that. In the case that we ever, want to change the color. All right. Now, the next thing we're going to want to do is go ahead and help the rectangles move, right? Or help the apples move, right? Because currently what's happening is that we have our apples in one area, all right? But what's happening is that they're not moving. So each time we run this for loop, all we're doing is we're going to take in our apples at the certain index, all right, for that certain pipe, and we're going to take its x position and go ahead and minus 5 from that. Apples. Pause x minus 5. All right. Okay. And another thing we're going to want to go ahead and now we've successfully drawn our apples to our screen. So we can just go ahead and run that. So if I were to show, whoops, one sec. That's not right. Sorry, it was on the other screen, right? Okay. So as you can see, we now have our apples. All right. Go run main.go. Okay, now that we have that, oh, whoopsies, I forgot to add this on, minus 5. Okay, so now it should work. Okay, so as you can see, we have our bird, okay, and then we have this apple that's moving, right? But now the issue is that, watch what happens when this apple goes all the way across. It just doesn't come back. So what's happening now is that I have this apple that's just constantly throttling and putting excessive pressure onto my GPU. Now this will eventually lead my GPU to crash, all right, because it just can't handle that amount of constantly rendering it. So what I'm going to do is I'm going to take that apple, and I could do two things. I could, one, delete it, or I could take it and draw it and put it all the way back. That way we don't have to constantly render new sprites of apples. We can just reuse the same one. All right, and considering this is a very simple game, that's what we're going to use. All right, and another problem with that you saw was that when the apple was coming towards the bird, it wasn't doing anything. So we also need to do that as well. So first thing we do is go ahead and check to see if our current pipe, or current apple, is x position, and we check to see if 0 is greater. If it is, then what we now need to do is go ahead and take the apples, we just take the index, okay, and set its x position to 800. All right, I'm just gonna, whoops, on full screen that. All right, now that I hit enter, now watch what happens when the apple goes all the way to the end of the side. All right, let's just wait. Yeah, as you can see, it re-renders back to where it was supposed to be. All right, and that's, yeah, and what, yeah. All right. So yeah, and then it just re-renders back to where it's supposed to be. All right, but now one thing you might have noticed is that it renders back in its original position. Now to fix this, all right, what we need to do is just go apples.io and go into its Y position, all right, and randomly generate a brand new Y axis. So we're gonna go ahead and just yoink it from right over here. That's -2, by the way. Yeah, we're gonna go ahead and yoink that and paste it right there. And now, int32, oh, yeah, we have to convert this over to an int32. int32, okay. And now, when I run this, all right, and the apple goes, all right, and it's just going and going. And now the apple is gonna regenerate a brand new Y value, and now as you can see, it's in a very different position. I'm just gonna go ahead and show that one more time, all right? So it hits below 0, the coordinates hit below 0, and now it's in a new position. All right. And now the next thing we need to do is go ahead and check for a collision between the bird and the apple. To do this, make another if statement. All right. Now the way collisions work is that you can't collide an image with a rectangle. What you need to do is collide a rectangle with a rectangle. Now, the best and easiest way to do this is simply just to take the current values of the positions on the bird and create a virtual rectangle and check to see if they collide. So to do this, we're going to go if rl.checkCollision, check collision, no, not boxbeer. It's just going to be called rex, like that. Okay? And we're going to check to see if, so we're just going to check to see a collision between two rectangles. First thing we're going to want to do is go ahead and create a brand new rectangle. We're going to go rl.newRectangle, all right, and it's going to have the x coordinates, all right, where'd it go? Oh yeah, it's going to first of all have the x coordinates, then it's going to have the y coordinates, float, you have to use the float32 method, by the way. Y coordinates, all right. The next thing we need to do is go ahead and specify the image size of the rectangle. And that's, yeah, we're going to specify the image size of the rectangle. And what that is simply just the width and the height, all right. So that's why I told you guys earlier, if you remember, to make sure you know your image size. Now my images are simply, what's it called? They are 34 by 24. So I'm going to go float32. 34, comma, float32, 24. All right, now that's one entire, where'd it go? Now that's one, crap. God damn it. Okay, yeah, so that's one entire rectangle. All right, now, one rectangle. Now we go ahead and figure out the other rectangle. All right, so to do this, we're going to, so to do this, what we're going to do is just go ahead and generate another rectangle for our apple rectangle. So we're going to go comma rl dot new rectangle. Actually, let me just zoom this out a bit because it's a little bit messy. Okay, yeah, this looks much cleaner. So this is our first rectangle method. Now this is our second one. We're going to go new rectangle. All right, and we're going to go ahead and first of all take in float32, all right, and it's going to be our current pipe.x, all right, and the next thing we're going to want to do is go ahead and get the current pipe float y, all right, next thing we do is just get the width and the height, all right, float32, current apple.width, float 32 current apple dot height. Okay. All right. Okay. Now that that's done, what we will want to do now is do something similar as to what we did when the apple went all the way back. And in fact, we can just go ahead and just yoink that over. All right. Okay. And boom. Now our apple will supposedly go ahead and move back. So let's just go ahead and test this out. So I'm going to go ahead and run. Okay, now here's our game, right? Now the Flappy Bird is going up. All right, and as you can see, when it ate the apple, the apple just disappeared and it drew right back onto the screen. All right, now that that's done, let's set up our end screen and our point system. Making a score account is actually a lot easier than you'd think. Let's think about it for a second. So each time the bird collides with the apple, we basically earn a point. And if it, goes all the way to the back, well, you basically would have to lose a point. So what we should do is first of all go ahead and create a variable called score, var score, and it's going to be an integer obviously, and set that equal to 0. Make sure that's before the for loop, because then it's going to reset in terms of value. The next thing we're going to want to do is go ahead and subtract when it's at the left side of the screen, and go ahead and add when it has touched an apple. All right, now we've gotten our basic score-based system ready. Now we need to go ahead and write this onto the screen. Luckily, Raylib has a really easy way of doing this. First, let's head on over to line 38 where it says begin drawing. All right, and right below that, go ahead and write rl.draw, and we're going to write draw. We're going to write draw text. Yeah. All right. Actually, let's actually draw that right below the texture. All right, this is because I want that to pop up first. All right, and we're going to draw text. And the text we're going to draw, right, is the current score. All right. And then what I'm going to want to do is actually just go ahead and import the string conversion method. All right. And now we're just going to go ahead and convert over the score into a string. String conv dot. All right. And we're just going to grab in the score. The next thing we're going to want to do is specify where the text will be located. I want it to be located at the top left. So, or more specifically at the 0, 0 point, right? So this is my x coordinate and this is my y coordinate. Then what we want to specify is the font size. So I'm going to go with 30. And we need to also write in a color. I'm going to go with the light gray color, rl.lightgray. All right. Now let's go ahead and run this and see what we have so far. All right, we have our player and we have our bird. Now watch what happens when I click it. As you can see, it re-rendered once again, and it renders like each loop, right? So yeah. Now watch what happens when the apple goes all the way back. As you can see, we lost a point. All right, now that's all done. Now the next thing we need to go ahead and add is an end screen. Our end screen will occur when the bird falls to the ground. When it falls to the ground, the game will end, and it's going to simply display your score. All right, so we know that the bottom of this, or the height of the screen is 450. So all we really need to go ahead and check to see is if our y coordinates are greater than that height. If it's greater than that height, it's simply going to go ahead and, return the score. All right, so head on over, Head on over outside of our for loop, okay, because we don't need it inside of our for loop, right? If the y coordinates is greater than or equal to 400, or actually just greater than 450, what we need to now do is first of all unload our texture. We're going to want to unload the texture because we want to save, computing power. All right, so unload rl.unload texture, and we're going to want to unload the texture. The next thing we're going to want to do is go ahead and set our apples to nil. All right, so this will do is take in our struct and just, clear it all, because we don't want it to end and then our apples are just floating around, right? Because that's a waste of hardware. Then the next thing we're going to want to do is go ahead and draw some text. So let me just actually yoink it from here. All right. your score is, or your final score is, okay? And what I'm going to do is I'm actually going to change the position where the text will be, and it's going to be at 30, 40. All right, and the size is going to be the same. All right, but I'm going to change the color to red. This is because you sort of lost, right? Now that that's done, let's go ahead and start this game up. All right. Now watch what happens when this bird falls. As you can see, our final score is just 0, and the texture has been unloaded from our VRAM. So that's all we've had to do in order to create our, the game. The game's basically done now. Now the last and final thing we're going to do is just add some sound effects. Alright, so in order to add audio into your video game, the first thing you're going to want to go ahead and do is, first of all, initialize your audio device. In order to initialize an audio device, what you need to do is head on over to your main function, alright, and before you guys do really any sort of, work, just initialize it right here, rl.init audio device, alright? The next thing you're going to want to do is go ahead and load in your audio files. So I only have one, as you can see over here, and it's just going to be eat_noise, alright? And I'm just going to go ahead and set that a declarative operator equal to rl.loadSound, alright, rl.loadSound, and the sound is just going to be, and then I just have to specify its path, which is just sound / eat.wave, alright, so it's a wave file. Alright, now that I have my eat noise ready, the next thing I need to go ahead and do is play it. So the only time I'm going to really play this eat noise is when it touches an apple. So it touches an apple right over here. So what I'm going to go ahead and do is this. Right after score ++, I'm going to go all the way down here and play it. So in order to play it, I'm going to go rl.play sound multi. Alright, I'm going to go ahead and play eat_noise. Alright, the next thing I'm going to want to do is, if the thing closes, what I want to do, alright, right above unload texture, is first of all stop any sort of music that's happening. So rl.stop sound multi, and I'm going to want to go rl.unload sound. Alright, I'm going to go ahead and unload the sound of eat noise. Alright, now as I said earlier, OBS doesn't really allow me to, play my music. Alright, I'm sure if I was a bit smarter I could find it out. But if you just run this, it should work. Now, one thing I do need to tell you guys is that it might take a second for the sound to play. This is not because of the way I wrote the code. It's just that the audio file has a 1-second delay. Like, it's literally paused for a second, then it plays the sound. So just go ahead and cut that out, I guess. Or, find a better audio file. But anyway, let's go ahead and load that in, right? And if I just go ahead and zoom up, right? Oh, whoops, I messed up. No worries, let's just try that again. So, yeah. So as you guys can see, there's going to be an audio, noise there playing. All right, if you guys can get that up and ready, let me know in the comments below. So that's it for this video. Today we learned how to make video games inside of the Go coding language. All right, while this hasn't been done before, or it has been done before, but it's not a very popular thing to do, I really think Go has the potential to, be a very, common thing in game development, hopefully in the future. So thank you guys for watching, and let me know if you guys want to see any more videos like this. Have a nice day.